Man, part 3. Part 3. So this is Unit 2, Lesson 4, Part 3. All right? We are going to start Part 3 with synthetic division. That's where we left off. And this actually, despite the name synthetic division, I believe is the easiest of all of them. It cannot always be done, okay? And here's a suggestion, all right? The divisor, which is this thing right here, that's the expression that's going into, that you're dividing into the larger expression. Okay, my divisor must be 1x plus or minus something, like I have right here. Okay, you see how my divisor right here is 1x plus or minus some number. Once you see that and you're doing division, you should absolutely 110% use synthetic division. Now, if this were a final and they did not tell you to use synthetic division and you had this problem right in front of you, x cubed plus 5x squared plus 7x plus 3 divided by x plus 3, and they said, evaluate this. You can use any division. You can use reverse tabular. That's fine. I'm going to show you another way, but again, you must have 1x plus or minus some number. Okay? That's just going to make life easier. Now, there's a process here, and it's simple. And as I write the process in the words, it's, sometimes it confuses people, but you should follow me here. The first thing you should do is you should take your divisor and solve it, which is like, it's the T-bone. Okay? So I'm going to take my x plus 3, like it was a booty cheek here, set it equal to 0, and T-bone it, right? So x would equal negative 3, because negative 3 plus 3 is 0. All right? That's the first thing I do. And this right here is where I start everything. Okay? That's number 1. Number 2 is I take the number I just solved. I take my negative 3. Take number from step 1 above, okay? And I place it in this, what I like to call like a half box or a backward L, okay? So let's do number 2 here. I'm going to take my negative 3, and I'm going to put it just like that in some sort of backward L. That's step 2. Very simple. It actually takes longer to write the steps out than to actually perform the math. Okay? Step 3. Oh, man, I should be color coordinating this. Like, for example, step 1 should be in black, so x equals negative 3. Okay? Step 2 should be in red, so then we put your negative 3 in red. Step 3, we'll do step 3 in green, okay? I'm going to take my dividend, okay? I'm going to take my dividend. That's my bigger expression. So I'm going to take the coefficients from my dividend. That's the bigger expression. I don't want my variables, so no variables. Okay? And write them horizontally next to that backward L. Okay? So I'm going to take the coefficients from my dividend. Don't want variables. I think the reason people like synthetic division, and let me just... I think the reason people like synthetic division is the variables go away. All right? So if that makes you happy and perks you up, it should. So what am I talking about? I want, okay, just my coefficients with, okay, I don't want any of the x's. Please note that in front of this x cubed, it's 1x cubed, isn't it? So I just want those numbers, and I'm going to write them to the right horizontally of my little L here. So I got a positive 1, I got a positive 5, I got a positive 7, and I got a positive 3. Okay, there you go. And again, I'm a buffoon. I'm trying to color coordinate this. This is in green. So I've got 1, 5, 7, and 3. So step 4. All right. Step 4. Well, I really should say horizontal line. Then actually draw a horizontal line. Okay, so I'm going to leave some space here, though. I'm going to put a horizontal line right here. Okay. Now, our other processes with multiplication and then ultimately with division revolved around adding and multiplying, right? We multiply, we add, we multiply, the same deal. Like we had to, be careful when we divided, going back and forth between the two operations. All right? So step 4 here is I drop it like it's hot. I drop the first number, okay? I multiply by my value in the L, and that product is brought up. Then I just repeat the process until I'm done. And let me show you. Then repeat. So, my first value, drop, 1. I multiply this value times this value, okay? So 1 times -3 is -3. That product gets brought up, okay? And instead of repeat, I add, I'm so sorry, then repeats. So I made a statement earlier, okay? I made a statement earlier. Division was really just adding and multiplying. Here's our multiplication. Boom, every number I bring up, I add. 5 and -3, well, that's 2. I multiply this number by this number. So 2 times -3 is -6. I repeat, add. That gives me 1. Okay? 1 times -3 is -3. I put that up here. 0. Now, my answer is what's below this green bar. Let me explain. This last one, in division, we can have a remainder, right? This last one is always your remainder. Always. This happens to go unevenly. I have a 0 for a remainder. And then what happens here? This term is where I have 0 x's. This term is where I would have 1x. This term I would have x squared, and it just goes up. So really my answer is x squared, it's 1x squared. It's a positive 2, so plus 2 x's and a positive 1, right? Plus 1. And there's no remainder. That's my answer right there. Okay? That's my answer right there. Now, I'm going to erase this, and I'm going to do it one more time before we practice this on our own. Okay? Without having to write this process in the whole 9 yards. So, bam, go. So I'm going to solve for x plus 3. So x plus 3 should equal 0, so therefore x equals -3. I put -3 in this backward L. I want the numbers with their signs, not the variable. So it's positive 1 in front of x cubed, a positive 5, a positive 7, and a positive 3. Get rid of all the letters. I draw a line down here, and this is where the fun starts. I drop, and I multiply. -3 times 1 is -3. I add, get 2, and I multiply. Okay, 2 times -3 is -6. I add, which is 1, And now I multiply. 1 times negative 3 is negative 3. I add, and I'm done. This is my remainder, the last one. Here are 0 x's. Here is 1x. Here is x squared. So I have 1x squared. This is a positive, right? Plus 2x plus 1. Done and done. When you get comfortable with it, that's how quick you do it. All right, so what are some rules for division? If we are missing any terms in my dividend, if I am missing any terms in here, I still need to fill in missing zeros. For synthetic division, you'll never be missing terms here, okay? Because this has to be x to the 1 plus or minus some number. That is fine. That's not missing any terms. But if you are missing any terms here, you need to fill them in with the 0. So when you go down here, if you're missing any terms, you got to put your zeros in, okay? All right. Let's try another one, okay? All right, I look at this thing. I see x, that is 1x minus some number 5. Beautiful, I can use synthetic division. That is much easier than doing the tabs, okay? Again, you don't have to. This problem right here doesn't say to use synthetic division. I mean, it says it here, and we're going to practice it. But if this were a test and you were given this, and you are comfortable with reverse tabular, and you're like, synthetic division, I mean, I know it seems simpler, but I always mess it up, then go ahead and use reverse tabular. But for the sake of our notes, we're going to do synthetic. Okay? So if I have x minus 5, and that was a booty cheek, and I had to T-bone it, so x minus 5 equals 0, x would equal a positive 5. That number is going in the backward L. All right? And I have a 1 in front of my x cubed, a negative 5x squared, negative 4x, and positive 20. I am not missing any terms. So it's 1 minus 5 minus 4 and positive 20. And I draw my line. All right? We always start by dropping the first one, and now I multiply. 5 times 1 is 5. And now I add. That gives me 0. Big deal. I can multiply 0 times 5. That gives me 0. I add negative 4. Okay, negative 4 times 5 is negative 20. Perfect, because when I add that, I get 0. That's my remainder. Here's my x to the zeros. Here's my x to the 1s. Here's my x squareds. I have 1x squared here. I have 0 x's, so I don't have to write that in my answer. And then I have minus 4. There you go. That's your answer. Okay? There you go. That's your answer. And just for poops and giggles, what I'm going to do is I'm going to do this using reverse tabular, and I'm going to show you that I came up with the same answer. Okay? So let me get some room right here. I know this is too tall, so I've got x minus 5. All right? Lefty, righty. And I know my outputs, my first one should be x cubed. This next one is negative 5x squared. Okay, I got this output. I have 2 more arrows I need. 1, 2. And that's negative 4x and 20. Those 2 arrows need vertical lines. All right, so let's do this. This has to be x cubed. What do I multiply x cubed by to get x? X squared. Negative 5 times x squared is negative 5x squared. So what do I combine with negative 5x squared to keep it? Negative 5x squared is 0. 0 plus negative 5x squared is negative 5x squared. What do I multiply x by to get 0? 0. 0 times anything is still 0. What do I add to 0 to get negative 4x? Well, how about negative 4x? And what do I multiply x by to get negative 4x? A negative 4. And if I multiply negative 4 times negative 5, I get 20. They match perfectly, so there's no remainder. And my answer is x squared minus 4. The same thing we got here. It's beautiful the way it works. Synthetic division is so easy. All the variables are gone, okay, until the very end. You take them out in the beginning, you just put them back in when you're all done. All right, let's try another one. Okay, I'm looking at this, and the first thing I notice is I have 1x plus or minus some number. Bells are going off, synthetic division. All right? So if I solve for that, if that equals 0, and I t-bone that, x would equal a positive 1. That's the number I'm putting in my backward L. Am I missing any terms? I have a 4, 3, 2, 1, and then 0 x's. I am good. So I'm going to take the x's out and just pull out my coefficients. I have 1 x to the 4th. I have a negative 2. I have a positive 1 right there. Should be consistent with the way I draw my 1s. I have another positive 1 here. And then I have a negative 1. All right, and I draw my line. Okay, drop the 1. 1 times 1 is 1. If I add them, I get negative 1. 1 times negative 1 is negative 1. If I add them, I get 0. Anything times 0, including 1, 1 times 0 is 0. If I add them, okay, I get 1. So inconsistent with my 1s. I just don't like doing them with the tails and the tips because they look like 7s. Anyways, 1 times 1 is 1, and if I add them, oh, my remainder is 0. Perfect. So this would be x to the 0, this would be x to the 1s, these would be x squareds, and these would be x cubes. So I have 1x cubed minus 1x squared. I don't have any x's, and that's plus 1. That, my friends, is the answer. And if I were to do this tabular, it would be a little bit more work. In fact, it would be a lot more work. Again, division is really just a series of steps of multiplying and adding. Okay? Nice. Let's try the next one. All right, as I look at number 4, I see x to the 4th minus 6x squared minus 27 divided by x plus 2. Here's 1x, and here's some number. Synthetic division, yay! Set that equal to 0, t-bone, x would equal negative 2. Negative 2 is the number I'm putting in my backward L. Now, I'm looking at this, and I am definitely noticing that I'm missing some terms. I have x to the 4, but I don't have any x cubes. I'm missing my cubes. I have x squared. I don't have anything x to the 1st. Again, if I have 4 is my biggest term, if my degree is 4, I need to have an exponent 3, 2, 1, and then obviously 0, which means a term that does not have any x's. Okay? I have 4 and 2, okay? I have 4 and I have 2. So for my 3 and 1, I'm going to have to use zeros, okay, for fillers. So really, I have x to the 4th plus 0x cubed minus 6x squared plus 0x to the 1s minus 27. This is division. Zeros matter, okay? They need to hold those places, okay? So if I were to write you a check for 10 grand and put a 1 there without any of the zeros, I think you'd say something, all right? So zeros are important, and we need them there. So let me write down my coefficients. This is 1, x to the 4th, 0, negative 6, 0, negative 27. Okay, and I'm going to draw my line. And I'm going to start this like I did everything else by dropping the first term. 1 times negative 2 is negative 2. When I add those, well, I get negative 2. Negative 2 times negative 2 is positive 4. When I add those, I get negative 2 again. Okay. Negative 2 times negative 2 is positive 4. If I add those, I get 4. 4 times 2, well, negative 2, is negative 8. And if I add these, I get negative 35. I have a remainder this time, and that's fine. We know how to write remainders, okay? Now, this is my remainder. This is my x to the zeros, where I don't have an x to the 1, x to the 2, x cubed. So I have 1x cubed minus 2x squared minus 2x, and that's a positive 4. That's a negative remainder, so I'm going to say minus 35 over what I originally divided in. We are done. After 3 parts, after 3 videos, we are done with this lesson. Why did it take 3 videos? Because multiplying and dividing, okay, the remainder, synthetic division, these are all important things to know. Okay, I really took 2 different lessons. I put them into one. So really in these 3 videos, we kind of did 2 separate lessons. All right, good luck, and I will see you for Unit 2, Lesson 5. Stay warm.